Right then, let's get started. So welcome to the OpenStack Charms project update. I'm James Page, I'm the current PTL and the OpenStack Charms project. Can I have a quick show of hands? Who knows what the OpenStack Charms are? Who's used them? Right, so I've got a couple at the back who probably want a bit of a general background first. So, what are the OpenStack Charms? So, the OpenStack Charms are a set of DevOps tooling that allows you to deploy OpenStack pretty much at any scale. So that's from an all-in-one install on your laptop through to hundreds of compute nodes in a kind of scale-out compute architecture. We cover most of the core infrastructure components and quite a number of the peripheral projects as well. I've been around for a while, so I think our first commits were way back in 2011. This is from our Nova Cloud Controller charm, which is one of the first ones that got written. We've been releasing probably on a 6-month cadence ever since that date. So we're generally in line with the main OpenStack release, and we now do an interim OpenStack release on the 3-month point between those two as well. Like I said, we cover most of the core projects. Some recent additions in that list include Gnocchi. So anybody using Gnocchi yet? I can't see anything because that's shining right in my eyes. Anybody using Gnocchi? There's 35 of you there somewhere. I can see how many people are using the charm, but that's a new charm that we introduced at the end of last year for newer OpenStack releases, providing kind of time series as a service backend for Ceilometer. As you can see, we've got most of the other core charms there. We have some kind of beta level charms for Panko, Trove, Murano, and I think we have one for Mistral as well. But if you want to fill in a gap, please do. Charms aren't that hard to write these days, so we have a bit of information on that a little bit later on. Okay, so just to talk about some of the underlying technology the project uses. So the first icon on the left there is Juju. So Juju is the tool that we use for actually deploying the charms. So the charms are the encapsulation of how to deploy each part of OpenStack. So Nova Controller, Nova Hypervisor, Neutron API, Cinder, Glance, Keystone, MySQL, RabbitMQ, all the various bits and pieces of software you need to run an OpenStack cloud. Juju takes those charms and it puts them down on hardware or into containers, and I'll talk about that in a little bit more detail in a second. When it's putting them down onto hardware, we use Ubuntu MAS, Metal as a Service, and that provides provisioning tools for deploying Ubuntu and other operating systems, in actual fact, onto hardware. So it's kind of a full data center operational deployment tooling, which Juju uses to put down various parts of OpenStack onto hardware. We have our friendly orangutan in the middle. It's not a monkey, it's an ape, just to be clear. And OpenStack, and the last icon on the right there is LexD. So everybody heard of LexD? Yeah, okay, so it came from LexC. It's probably, I don't know, 3 years old now as a project. It was a kind of a natural step forward for the LexD team to produce a daemon to manage LexC containers on an Ubuntu or actually a Linux install generally. And Juju makes use of MAS for hardware, and it makes use of LexD to put some of our services in containers on top of the hardware as well. So we can get a good converged, highly dense story whilst maintaining good separation between the services within the OpenStack cloud. Okay, so just talk about some of the features that we delivered in February alongside OpenStack Queens, which was the first major feature we delivered. We also made some changes into our Neutron and Designate integration. So how many people are deploying Designate in the room? One? I know we have it in, yeah, Dario does, but. So Designate is the DNS as a service project in OpenStack. Earlier versions of that integration were notification driven, so using the RabbitMQ message bus to consume notifications from Neutron and Nova to create DNS records. That method was deprecated by the Designate team a couple of cycles back. So we've now done the work to put in the driver in Neutron so that it directly creates records in Designate using an extension driver in Neutron rather than relying on the message broker to deliver that via asynchronous messaging. So asynchronous, B, integrated directly into Neutron rather than being a kind of more loosely coupled affair. So that was available in February. We had a preview for Ubuntu Bionic, which is the LTS that Ubuntu released last month. And we did the final piece of work to remove MongoDB from our stack. So MongoDB was the database backend for Ceilometer for some time. And the work we did around Gnocchi supersedes that and completely replaces it from Queens, Pike and Queens onwards, basically. So you don't need to run MongoDB in your OpenStack clouds for telemetry any longer. I know there was a particular pain point for some people because they get put in LXD containers and they maybe don't have as much storage as they need, whereas Gnocchi backs onto Ceph, and typically Ceph's on hardware, and it's much easier to scale out if you need to add more capacity, and that can be shared as a backend with Cinder and Nova, and potentially for object storage as well if you're electing to using the Ceph Rados gateway rather than Swift for object storage in your cloud. So this is this week's release. So I think we're going out on Thursday, aren't we, for the release? So we've got some nice new features for our 18.05 release. We've got a new charm for neutron dynamic routing. This allows you to expose the internal network topology within your cloud to the outside world via BGP. As you create networks within your OpenStack deployment from tenants, those can be advertised to the outside world via a BGP speaker to the rest of your routing infrastructure, which allows those networks to be routed to rather than NATed, which obviously has some efficiency in terms of bits of Linux getting in the way and slowing things down. We've got two security-related features, one around encryption of data at rest, which I'll talk about in a little bit more in detail, as well as TLS Certificate Management. So the charms have had support for managing SSL certificates for API services for some time. There were two ways of doing it. One of them was very much a dev test, internal snake oil CA type affair. So the recommended approach had been to use the configuration options that each charm has to provide certificates into deployment rather than deployment generating themselves. We've got a little more of an more elegant story using Vault PKI for managing that as part of a deployment, and I'll dig into that in a little bit more detail. We've got the full 18.04 LTS support, so that's for OpenStack Queens on Ubuntu Bionic. So that's now fully tested and released alongside or just after the actual Ubuntu 18.04 release. Okay, so let's look at two of those features in a bit more detail. Encrypted data at rest. So this really came out of a number of feature requests we had around how to mitigate risks of servers or disks being stolen from your deployment and sensitive data on those disks being compromised. It was being driven from a number of Canonical's European customers by the new data protection regulation that's come in Europe, which is making a lot of new demands in terms of securing of data that is potentially sensitive or contains personal information. So we looked across the OpenStack charms and said, okay, so where are the touch points where we need to encrypt data? So basically, the support we've delivered makes use of de-encrypt, so it's a kernel level encryption, which if you're running a moderately new CPU is all in hardware, so it's nice and fast as well. We're using the LUX on disk format to manage that. And we've integrated this into the Ceph storage charm, the Ceph OSD charm. So if you're using Ceph, your backend block devices will be encrypted underneath Ceph. So if someone walks out the door, they haven't got the keys to decrypt those block devices. For Swift and also for Nova Compute instance ephemeral storage. So if you're using QCOW on disk rather than a Ceph backend, you can provide a block device and that will be encrypted as well. However, encryption of block devices is really the easy part of the story. It's actually management of keys, which is the bit that's really important for securing your deployment. And as I said, we're using Vault for that. So is everybody familiar with HashiCorp Vault? Okay, about 20%. So Vault is a software-based secrets management tool. Forms part of HashiCorp's product range in terms of the various bits and pieces they produce. But it provides a nice way of managing secrets within your deployment and then the operational processes around securing those secrets as well. So for this integration, we're basically using the simple key value storage backend, which allows us for a given block device to store a de-encrypt key in Vault. But in terms of how those secrets are secured is really quite elegant in the fact that to unseal a Vault unit, which as part of our deployment, you have to provide a number of unseal keys to actually unlock the master key. Those in a OpenStack Charms managed deployment are not managed as part of the Charms. They're managed outside of the environment. So the use case there is that the operator who's deploying the OpenStack deployment, which includes Vault, will deploy all that stuff. Vault will come up in a block state saying, I need to be initialized. And that initialized state will then operation, which is done via the remote API of Vault, will give the operator the unseal keys for the deployment. They can then unseal the deployment, pass a one-shot token to the charm, which then allows the charm to grant itself some access into Vault to be able to do things like manage the secrets backend on behalf of other charms requesting access to that. But the operator still maintains control over the master keys. They're not stored in the Juju model anywhere. The idea is they're stored outside of the model. So if someone walks out of the data center with all the servers that constitute your OpenStack deployment, when they turn them back on, none of the data is available because the Vault units come up sealed. Unless you've got the keys to unseal those units, there's no way you can actually get to the keys, so you can't unlock the block devices, and the kind of touch points about where you may end up with personal information are completely secured within your deployment. Yeah, deployment loss. Yeah, someone steals my rack. Yeah, so the idea is that those unsealed keys are absolute gold. You keep them outside of the deployment, probably in a different system and different set of racks, or they could be owned by people. That's the other thing. So that's quite a typical thing. You need like 3 out of 5 shares to be able to unseal the master key, and then your units can be operational. It does have some operational impact. So like if you need to update Vault to a new version, you need the unseal keys to then unseal the unit once it's been restarted. So there's some operational considerations there that need to be taken into account. We're also using Vault for the new TLS Certificate Management solution that we've come up with. So Vault provides a PKI backend for managing certificates. The initial implementation that we've delivered puts the Vault PKI in the role of an intermediate CA for the deployment. So what this allows us to do is for Vault to act as the signing authority for all the services within the OpenStack model that's being deployed. The way that's set up is that when Vault's deployed, it will create, when you run the actions on the charm to request a certificate signing request for the intermediate CA, it creates the intermediate CA and its keys, generates a certificate signing request, and then typically you'd sign that with your corporate root CA infrastructure, and then pass that signed cert back into the deployment. And anything that trusts your corporate root CA can trust whatever's in the deployment. So for a private cloud deployment where you don't want to pay VeriSign or whoever it is for publicly signed certificates, it's a nice solution because it allows us to completely automate the generation of certificates, eliminating a lot of the fiddly end user errors that can happen if you get your SANs wrong or your DNS names wrong or whatever it might be. And it means that the Vault PKI and the charm can then issue the certificates for the whole of the deployment with a good level of assurance about that that's actually going to be operational at the end of the deployment process. We're going to complement that with 2 other features in the upcoming cycle. One of them is the ability to provide a bundle of signed certificates by a public CA, so a VeriSign certificate bundle, if you need to provide public API endpoints out to the outside world. And the other is a snake oil solution that if you want to use it for dev test, you can use Vault PKI as a root CA and just have it signed certificates for the whole deployment. That's obviously not one for production usage, but if you just need it for a dev test type environment, it saves you going through any signing process at all. You just need to grab the CA from Vault after the deployment's finished and use that as in your certificate trust chain for your clients. We're also going to be expanding that to cover more than just the OpenStack API services, which is the initial phase, to include securing TLS endpoints for RabbitMQ and for Percona Cluster as well. Percona Cluster may be a cycle out yet, but RabbitMQ has most of the scaffolding needed already, so that shouldn't be too hard to do. Okay. Excuse my cough. So our next 2 releases are in August and November, respectively. So August release will focus predominantly around support for OpenStack Rocky. We generally put out an aligned release which introduces support for the new OpenStack release on the OpenStack release day. So from that day onwards, you can deploy the new OpenStack release using the new Charm release. We've got a few OpenStack-related features coming in. So we're anticipating some work on Cells v2, enabling Fernet token support, which I know people have been asking for a while, but UUID is now gone. So for Rocky, that we really do need to do some catch up there. We've got a Panko charm, which has been in development for a cycle or so now, and I think we're now getting to the point where that will be ready for release alongside the rest of the telemetry stack. Some validation work around Ceph Blue Store. So we've had Blue Store in the charm set for a while now, and we just need to do the validation work to prove A, it's resilient, B, it's more performant than the fast store option that we default to at the moment. So you should see some more automated testing coming out of the OpenStack Charms project around that for continual validation and regression detection. And I think we're hoping to do some sort of white paper off the back of that to show the performance comparison between Faststore and Blue Store and how that's enabled as part of as an OpenStack Charm deployment. And we're also going to do some work on Octavia for load balancing. LBAS v2 has been officially deprecated. It's got a bit of life left in it yet. But I think we've had a number of feature requests for supporting Octavia, and it's more instance-oriented way of doing load balancing rather than on host as we do now with LBAS v2, which should give us better scale of that service without impacting on gateway units that should be handling north-south traffic routing rather than dealing with HA proxy instances. So kind of beyond those timescales, we've got a long-standing spec that we've never really got around to implementing, which is around consolidating our API load balancer, so you can have a single entry point to your cloud for API services. And we've got some of the wider Charms community. We've got a little bit of engagement from an educational institution who want to do some work around charming up OVN as an alternative SDN for OpenStack. I think that's coming out of the OPNFE forum. So. Okay, a few details about how you can get involved. We hang out on IRC, we have weekly meetings, and you can get us on the OpenStack Dev mailing list and some of our documentation as well. Ways you can contribute. I know I was talking to this gentleman here outside just before we came in about different ways you can get involved. And really, we've got a couple of minutes left for questions. The guy at the back's waving at me frantically to tell me we've got less than 5 minutes left. So if anyone's got any questions, I'm happy to answer them now, or we can go downstairs and I'll answer them over a beer. It's up to you. Go on.
Came over from the room next to this.
Yeah.
Perhaps Kubernetes. Would you compare the Charm way to the Kubernetes and Charm way, managing, deploying, Openstack?
Oh, that's a good.
No, but this is probably not for 2 minutes.
Yeah, that's not going to fit in 2 minutes. That's definitely one for a beer. So some of the concepts are similar. We use containers in quite a different way. So whereas Kubernetes is very much application containers, we're using LXD containers, which is a full system container. So it's kind of a bit more of a traditional approach to servers in that you can monitor them with Nagios. You can do all the link them into your existing monitoring infrastructure in much the same way as you do any other service. I mean, the GG provides a lot of the same constructs that Kubernetes does in terms of how you apply upgrades, how you do configuration changes, that type of stuff. So there's a lot of similarities. Yeah. There's a lot of differences as well. So, yeah. Any other questions? Okay. Well, thanks very much.